options that we could have to ship this microbial fuel cell to other countries, we thought, well, we should just make this as a kit. And one of our plans and one of our goals for our microbial fuel cell was to use attainable ingredients such as vinegar, table salt, and baking soda. But then we also had other salt solutions, so we decided that the kit for our microbial fuel cell would include this to salt, the filter, a year-long supply of filters, in the overall microbial fuel cell. And also a user manual was created for the rest of the ingredients. And the manual has different measurements in table salt and tablespoons that can be easy to recreate by a customer. It was also found that the unit cost for our final microbial fuel cell would be about $10. This was this price was accomplished by analyzing all the different materials that our cell is composed of. So for the future work and upgrades on our cell, what we could do is to add platinum-loaded graphite electrodes onto the graphite electrodes that we already have inside our cell. It was found in the literature and in the research that we did when we first started the project that the power that we are actually obtaining could be increased from 1,000 to 10,000 times the output that we already have. And by combining different material species, our output could be increased 10 to 100 times the output that we have in our microbial fuel cell at the moment. So for the best case, we would have to have just less amount instead of the 200 million cells that Jeff mentioned earlier. We would only have 20 microbial fuel cells to power a 100-watt light bulb. Or in other words, we could even use less than one microbial fuel cell to power up a iPod Touch. And on our conclusion, we have a successful prototype. It was mentioned at the beginning of the presentation that the main goals were for our project was to be sustainable, portable, simple to operate, and very inexpensive. We achieved all of these goals by creating our microbial fuel cell with very inexpensive materials. And we have shown that the technology has a lot of potential by doing some upgrades to the cell. So right now we are currently obtaining 22 microwatts per meter square of electrode, but some similar cells have produced 10 to 20 milliwatts per meter square of electrode. This is 100 times the output that we are already obtaining. But this could be obtained by adding platinum to the electrodes that we have in the cell. So some acknowledgements. We want to thank Professor Seitz, Professor Wirtz, Mr. Schoolhouse, Professor Van Edwards, Ben Johnson, and Membranes International. They all helped out a lot in the process of our project. And do you guys have any questions?